Hi, my name is Roland, and who knows my channel knows that I have built a DIY Powerwall. And today I want to tell you a situation which I had after I built the Powerwall and a small problem which I tried to find a solution for. And the story is about that after I built my battery pack. It contains 48 lithium iron phosphate cells, and it is built as a 48 volt pack. So I had one cell over. I ordered 49 cells in case of there is some problem. And so because when I got my cells, actually all of the cells have been in a pretty low state of charge. Also the last cell which was left over was maybe just a 10% state of charge. So my plan was to put it into some kind of storage, and if you want to store lithium ion cells, you should store them with about a 50% state of charge, just to make sure that the cell is keeping their life alive, right? So but my problem was I didn't have anything to charge a single cell, a lithium ion phosphate cell. I had a simple battery charger for the normal lithium ion cells, which goes for 4.2 volts, but it doesn't recognize the lithium ion phosphate chemistry, so it cannot be used for that. I also don't have a power supply, like a lab power supply where you can set the voltage and the amps, and you could do something like that. Some other options to use some cells from the existing pack to transfer some energy also did not play out, because I don't have balancing of that pack. So if I would take away energy from some cells there, it would be out of balance then as well. So nothing like that too. So let's show you what was my final solution for the problem which I found. And for those of you who are a little bit new to solar equipment and stuff, battery stuff like that, it might be some kind of surprising solution. But I will show you how it exactly works, and so you can understand the physics and the basics behind it. So the only thing I finally found was a single solar panel. Right, this is a 12 volt, 20 watt solar panel. This is my extra battery. And as it sits now here, it will be probably about 40% charged, and it is a little bit missing for the goal of 50%, right? So how does this device, which is a solar panel 12 volt, fit to this one battery cell, which is a 3.2 volt nominal battery cell? Can this be connected together so that we can charge the battery cell just with the solar panel? So keep in mind, no charge controller, no MPP charge controller, no PWM charge controller involved in this. Just connecting those two wires straight to that cell. Possible or not? For that, to answer the question, we have to actually check the datasheet of a solar panel. And in the datasheet we will find something like this, and it is called the panel current voltage curve, and it is showing one side here the current and voltage, and how much current and voltage is produced basically if you add a certain load, right? So there's 2 points in this chart which are interesting for us. So one is the upper end is called the VOC, or the open circuit voltage. You can find these voltages just on the back of every panel. It doesn't matter which panel you have, there's always a sticker on the panel in the back, and you can find those values printed there. So the VOC, open circuit voltage, this means these 2 wires here are open, right? Nothing in between, open. So this is open circuit. Then the other end is the SC, so the short circuit current. This one will happen when you would connect these two here. We just put this together. Right? Now we've created a short circuit, and this will generate a certain amount of current. So voltage 0, maximum current. Voltage is the maximum zero current. And usually when you use a solar panel with a solar charge controller, like a MPP charge controller, MPP stands for maximum power point, that charge controller will find the optimal point where it can generate the maximum power at a given time for your solar system, right? But in our case, we don't have any kind of charge controller. So how can we use this curve in our situation, right? For our situation, the battery cell. So this battery cell will become our charge controller. So here you can see the sticker. The VOC is 14.16 and the ISC is 1.86 amps. So if we take the 3.27 volts, here 14.18 in our case, and you draw the line up here to the current, we can see we should actually expect almost short circuit current. It's not a maximum power point, but of course it is a power point. So the solar panel will supply almost its full amperage. So let's try this now and we will see if we are right in our assumptions or not. Okay, I take the alligator clips here, connect plus and minus. So solar panel directly connected to the battery cell. You see the voltage did not change because the internal resistance of the cell is very, very low. So voltage should not change at all. Now we will check the amperage. Okay, DC amperage, zero it out. And look at this, we have 0.64 amps going through now and charging the battery, right, with 3.27. So 14 volts from the panel did not generate some over voltage condition, as maybe some of you would have suspected, but you have to see this battery cell is like an infinite power drain, so it will always pull down the panel to its current voltage until it's full. When the battery cell is full, of course, that would make then the voltage rise towards the voltage of the panel, and then we would of course exceed the rated maximum voltage of the cell. But until the battery is not full, there's absolutely no danger in this procedure, right? The battery cell has a capacity of 100 amp hours, and we are now putting out 0.64 amps, and maybe we can generate power here for the next 5 hours. So we would only put maybe 3 or 4 amp hours into this cell today. So absolutely no problem, you don't even need to check on it. Nothing happen for the next 10 days. We can continue this situation for the next 10 days and it would still always be within the safe limits of the battery cell. Yeah, so this is an example how you can help yourself out in a situation where you don't have any kind of equipment. A device like a solar panel can function as a power source and a charge controller in one. I hope you found it interesting, and thank you for watching. If you're interested why I do not balance my pack, then please check my playlist. And if you did not see yet how I have built my Powerwall, then you can also check on my other videos. So thank you very much for watching, and I take up to you next time.